All right, hello everyone, and welcome to the April Modern Workplace Security Call, where we will discuss threat protection with Azure ATP. I just want to make sure that everybody is able to hear me. So if you could, in the message window, just tell me the last piece of fruit that you had. I heard her saying earlier today, can't compare apples to oranges, so that's just up in my head for some reason. So if you can hear me okay, just in the message window, type the last piece of fruit that you had. For me, it would be a banana. All right, great. I see one answer coming in, so I'm going to assume that you can hear me. If there are any issues with the slides advancing or anything like that, first thing you should do is refresh your browser. That should catch everything up. Other than that, just send me a message within the message window, and I'll see if we can troubleshoot that for you. Last thing is, during the presentation, please feel free to use the message window to ask any questions. During breaks in the presentation, I'll be asking Travis, the speaker, those questions as they come in. And lastly, this event is being recorded, so if you do not want to be recorded, this is a great time to drop. No worries there, because the call recording as well as the presentations will be available after the call. The deck will be available at our Yammer site, and I'll type that in the message window, but it's aka.ms/MW partner community. And the call recording normally takes about a day or two for the call recording to appear, but that'll be at our YouTube channel, which is aka.ms MW call recording. Just a couple of things I want to make sure you guys are aware of. We do have new technical communities. We've been sharing this information for all of our calls. So the technical communities have been tied to our solution for solution areas of focus, and then open source solutions. So with that being said, our communities that we focus on are Modern Workplace, which you're here listening to today, business applications, apps and infrastructure, data and AI, and then open source solutions. So each of those communities have their own monthly calls. Within Modern Workplace, we actually have 3 monthly calls, one for productivity, one for security today, and then one for Windows and devices. Normally the Windows and devices is held on the 3rd Tuesday or 4th Tuesday every month. Just want to make sure you guys know that call has been pushed out a week just to make room for the speaker. And I'm actually going to send, when we send out the final deck, the links to all these communities, Yammer communities, will be in that deck. And that's about it as far as intro is concerned. Again, remember, if you have any questions that pop up during the presentation, please ask them in the message window, and I'll be sure to make sure we address them during breaks in the presentation. So without further ado, I will pass things over to Travis to discuss threat protection with Azure ATP.
Welcome and good day, everybody. My name is Travis Gwynn. I'm a cloud security architect in the One Commercial Partner Group in Modern Workplace. Today we're going to talk about the new Azure ATP and threat protection. So we want to start off with the anatomy of attack. So what Azure ATP is, if you don't already know, it's kind of the next evolution of advanced threat analytics. This is kind of the cloud-born version of the ATA. And what we're doing with Azure ATP is looking at how attackers infiltrate your environment and start beachheads and the behaviors and authentication traffic, etc. So the way this typically happens is attackers get into your network through phishing scams. The rate of turnover from those is surprisingly high. Sending in emails and with legitimate looking emails, trying to trick a user into clicking on a link that might download some malware or allow some other type of exploit. So once that attacker is in and they get access to that user's computer, that account becomes compromised. That compromise then allows the attacker to perform actions on that user's machine in an attempt to get elevation. Right. So some of these things they get really interesting in that sometimes they attack like common applications. Say the Office stack or help desk or even browsers, and they'll attack them such that they make them crash, and they're making them crash in an effort to get a help desk person that has administrative privileges to come and log onto the machine. And what this does is it allows them then to hijack those administrative credentials and then begin what they call lateral movement from one machine to another until they find, if they can get somebody onto that machine, it makes it that much easier. Otherwise, they can get to other machines and find one that has an admin that has logged in. And then once that privileged account has been compromised, then the attacker can really get into the sensitive data and do an exfiltration. So what you want to be able to do then is how do you go about detecting the credentials when they do become compromised? How do you identify or know that the user's account has been breached? So how do you find out how those attackers are moving around from machine to machine in your environment? If you know what pass the hash or pass the ticket is, these are attacks where the attacker compromises, or they don't really need the user's password in clear text. They can get the password hash out of the memory of the workstation, and then take that information and actually pass it to other machines where it's just as good. Right, you don't actually need the password in clear text. You can use just the hash or the Kerberos ticket. And rule-based security, it's not enough, right? Because at this point, they've compromised credentials that have access, right? So you can't deny your normal user's access because you don't know that they've been compromised. So what we want to do is take a look at detecting this throughout all the different attack stages, right? So it's not just about Azure ATP. It's about the entire Microsoft threat protection stack. This begins with Office 365 ATP and email protection. If you have an O365 account, you've probably noticed that when you get an email that has a URL in it, if you hover over it and you see what that URL is, they often, or you'll see it where it says safe links. What that's doing is Office 365 ATP is actually looking at those URLs, and when you click on that URL, we're actually looking at and examining the safety of that URL. Some threat protection products will go in and they'll scan incoming emails, and they'll see a URL, and they'll go test it to see if it's a valid URL. That there's no malware. And if there's not, what they'll do is they'll authorize that link. But what happens is attackers can do this a bait and switch. So they send out an email. They see that the threat protection has accessed the URL, and then once they see that there's no malicious payload at that site, they actually switch out behind the link, and they replace that safe website with one that has malware behind it. And what happens is they don't. It's already been authorized, so they miss out on the change. Well, so Office ATP is actually evaluating the link when you click on it. That's what the safe link is for. So it's really cool that they can't do this they can't pull this bait and switch on Office ATP. The second one there is, in the event something does get through, right? No system is perfect. So in the event that something does get through, or you don't have Office ATP, but you have Windows Defender ATP, this is the next step here, right? So Windows Defender ATP is going to be looking out for any kind of exploits or unauthorized installations, or actually checking for known command and control channels, like for botnets, right? So you probably see in the news Microsoft actively looks for and busts various botnets. We keep track of IP address ranges and domain ranges and activities, et cetera, that identify various machines as being a member of a botnet. So if then it does make it beyond Windows Defender ATP, the next step there is Azure ATP, and what we're looking for there is so the attacker has made it into your network, and they're on them. They've taken control of a machine and managed to circumvent both Office and Windows Defender ATP. The next step is Azure ATP, where we're going to be looking for authentication behavior on your internal network, right? So Azure ATP, just the first question there is it's looking at your local domain authentication, not Azure AD authentication today, but it's looking at all of that information where accounts are coming in, because one of the first thing a user's or an attacker is going to do when they get into your network is do recon. They're going to go off and do like DNS zone transfers. They're going to try common usernames and group names and get membership levels and things like that. And then once they have an idea of what's going on in your network, they start moving around in it from one machine to another until they can find one that gives them administrator privileges. And once they get those admin privileges, and they can start getting the pass the ticket, and they get like a Kerberos golden ticket. Now they have essential domain dominance, right? They've gotten on a domain controller. They've installed various services and things that kind of keep them in there, even if you think you've gotten them out. And they own your domain, and a lot of times you don't even realize it. So what Azure ATP is doing is looking through all of these activities through various information going on your domain controller. So essentially every packet that goes across the wire into your domain controllers, all the events, all these things are being looked at and evaluated, and we're looking for all of these activities. So things like abnormal behavior. If suddenly a user starts adding people to, say, the domain admins or enterprise admins account in the domain, and that's not a normal behavior for that user, we're going to alert on that. We can see malicious attacks and various security issues and risk, and we look to try to alert you of these activities, before damage is caused, or before someone can actually achieve that domain dominance and be able to exfiltrate your data. Some of the realities here is the 99 plus, right? And I've seen this number vary based on the report and who's doing the study, et cetera. But the gist of it is attackers are in your network for months, usually before any IT system even detects them, right? They're in there. They're not really doing anything active. They're just kind of hanging out and watching to see what's going on. Over 81%, of breaches are leveraging either stolen or weak passwords, right? So not just Azure ATP, but our cyber defense center is actually out there looking on the dark web, looking to see if credentials are for sale, right? And we look at those to see, and if they are for sale, we enter those, and now this is more on the Azure AD side, but we work to see, hey, this account has been compromised, and then we can inform or use some intelligence and requirements on the Azure AD side to say, this account's been compromised. We've found valid name and password on the dark web, so the next time this person tries to log in, they're going to have to say use multi-factor authentication, and they're going to be required to reset their password and things like that. 500 billion, total cost of cybercrime to the global economy. Another number is $17 million. The average cost of a breach to a company, and that's response, that's replacement, that's overtime, that's cost in market value and lost sales, et cetera. So your average breach is around $17 million. So that's any time that you see a pushback on cost of various security products or protocols or methods, it's probably a lot less than the cost of a breach. And then the last, that says 3.8 million. It's actually about 7 million. This one's a little behind. So, but about $7 million is the, $17 million, and that's total cost, right? That's including this one's not the 3.8 doesn't include like what we estimate lost market value, et cetera. So the second thing here is we can benefit from the cloud scale, right? So if you're familiar with advanced threat analytics, all of that processing, all of the storage exists on premise. With Azure ATP, we've moved all of that to the cloud. So now not only do you not have to worry about the actual physical disk storage and processing power, we can also iterate updates and apply machine learning in real time to the threat detection that's available in Azure ATP, right? So you can really get through, and I mean, we've already, a new preempt attack has just come out within the last couple of weeks, and we've already iterated Azure ATP to be able to find that. It's very easy to deploy. There's no hardware requirements in your local network beyond having enough processing power on the domain controllers, but it's everything. It resides in the cloud, and you only, for the most part, you only need what we call the Azure ATP sensor, which is just a little filter driver that gets installed on your domain controllers and forwards all that information up to the Azure ATP processing cloud. So the architecture is really simple. For every domain controller in your network, you'll have an Azure ATP sensor installed. You can also use what's called the Azure ATP standalone sensor. This is closer to the ATA gateway that you may be familiar with from ATA, where you're actually doing physical networking port mirroring, where all of your domain controller traffic goes through that. The standalone sensor can also forward alerts and such to a SIEM. And you're pulling Windows event forwarding. One of the advantages of using just the ATP sensor is that all that happens automatically, right? You don't have to configure some of these extra things, but all of that information gets uploaded to Azure ATP Cloud, and then your administrators then access that console and have all the information available there and online. And another really cool feature that you don't have with ATA today is the integration with Windows Defender ATP. This is another cloud integration because they're both cloud services, and we can integrate those. And there's going to be more cloud integration as it progresses. So, like I said, today we're only looking at user accounts and user activity on your on-premise Active Directory. In a future version, we're going to be including Azure Active Directory accounts in that as well. So what we want to do is really look at what's actually important. It's similar if you're familiar with ATA again. The attack timeline that you get in the ATP console is very similar. It's that almost social media looking feed where it's a timeline. At this time this happened, this time this happened, and it's very clear and kind of plain language as to what's going on, right? And then you can. But then the power lies in the ability to open those events and drill down deeply into the information. So the new thing here is this profile timeline. So you can, if you see in one of your alerts a particular account is having some issues, you can actually drill into the account. So in this particular situation, we have Jeff Victim. So when you click on Jeff Victim, you can bring up Jeff's profile here and show, you got your email address and his office and his all of his pertinent data there. But then you see the timeline of all the events that involve Jeff, and I'll show you that live here in a few slides. So the first thing is Azure ATP setup. It's very simple. Once you spin up the license, all you have to do is you log into portal.atp.azure.com. The first thing you're going to be prompted with is to create a workspace. You can create multiple workspaces, but you do have, one of them will be a primary. And the reason we have that concept of a primary workspace is only one of the workspaces can actually be integrated with Windows Defender ATP. So you'll create that new workspace. You'll be prompted for a name. Is it or is it not the primary? And then a geolocation. And once you select the geolocation, it is tied to that. That doesn't get changed. And we have 3 right now: Asia, Europe, and then the Americas and Caribbean. So the next thing you have to do is go into the configuration and essentially give this what comes down to a service account. So you give it this directory services account. This account exists in your local Active Directory, provided the username, password, and domain there. And that's what we're going to use as the source for the directory syncing and to deploy the sensors, etc. So the next step is, once you've configured that, you have to deploy the sensors. So each one of the sensors then it's pretty easy. You go into the sensors and you can download. It'll download a zip file. The zip file will contain an exe and a JSON file. The JSON file will be the configuration, be able to connect that particular sensor back to this ATP workspace. You'll need to copy that access key. So when you do the install of the sensor, you'll execute it, you'll give it the JSON and the access key, and it creates a one-time password for that sensor deployment. And after that, all the communication is performed between the sensor and the web service, then using certificates for authentication and TLS encryption, right? If you need to, you can regenerate if you need to, and that does not disable any previous ones, but you can regenerate and use a new key for additional sensors. Sensor installation is really simple. Just run it, pick your language. It actually automatically detects whether you're on a domain controller or not. If you're on a domain controller, you just get the sensor. If you're not on the domain controller, it'll automatically detect and install the standalone sensor. You provide it the installation path and that access key, and it'll install. So once that sensor is installed, you can come back into the portal and go to the configuration. There's a couple of other steps and things that you can do. You can go into entity tags. You can specify what's called a honey token account. So what this is you can go in and specify an account that we call a honey token account. And what this is you can, a lot of customers go in and rename their administrator account to something else. So they can create another account, call it administrator, and then specify that as the honey token account. And typically these accounts are things that aren't ever logged onto, right? So what happens then is if an authentication event occurs where somebody tries to log on to it, whether it's successful or a failure, we're going to alert on this, especially every time, because we know that account should never be logged into. You can also designate what are called sensitive accounts. Sensitive accounts are specially tagged, and we take a closer look at those accounts when they're brought up. And you can have multiple sensitive accounts. Pardon me. We automatically tag the domain admins group, enterprise admins group, and their members as sensitive accounts. But you can also come in and manually tag users or groups as sensitive as well. And I'll show you more about that in the portal. Exclusions, I apologize. This one's a little small. But you also have some exclusions here, so and various events. You can add IP addresses or computer names in here to exclude them from various alerting on various events. And this could be in different scenarios where this machine is used for a specific function, and you expect these events to be coming from that machine. You don't want to see those alerts. So now what I'm going to do is I'm going to switch over to share my desktop here and kind of take you through the Azure ATP console. I'll give it a few minutes to come up. But what we're going to do is I'll show you the Azure ATP console and kind of take you through what it looks like to kind of follow an attack and how you can drill down through the various information. And if you've used ATA, this is very similar. So this will look very familiar. So in this particular case, what we're doing is just looking at this timeline. The timeline gives you shows you. So what we're seeing here is reconnaissance using DNS. So typically what we see a lot of is attackers will infiltrate a network and then try to do, say, a DNS zone transfer. And what they're doing is looking to try to get all host names in the network. A lot of times, and a lot of customers, they name their machines as by function, right? So it's DC01, DC02, or SQL01, SQL02. And what that does is those DNS names then give those DNS names and IP addresses provide the attacker with a map of your network. So for customers that don't name them by function, or makes it a little bit harder. Certainly, it's just one minor step there, but it does make it a little harder. But what we're going to do is see that somebody from a victim PC here tried to do a DNS zone transfer, and you can dig into this. Oops. There it is. You can dig into this event here and see that victim PC did a DNS query off to Contoso DC and tried to do a AXFR DNS zone transfer, and it was denied. Because that's typically a valid DNS configuration, is to not allow zone transfers to unregistered DNS servers. So even though it failed, though, we see that the attempt was made, and it's still a valid alert to see that, hey, this looks a little suspicious there. All right. Have this reload. There we go. My website had been sitting idle for a while. So, all right. So the next thing that, so the attacker, so that was, so that maybe that failed, but so the next step then is they do a recon using SMB session enumeration. And in this particular case, you're actually seeing that, it's done under the guise of Jeff Victim's user credentials, right? And it will show you at what time Jeff Victim, tried to do this SMB session enumeration against your domain controllers. It also noticed here that it exposed the NUC Chorus account, right? So we don't know exactly who that is or what significance that has in the network yet, but it has exposed that. All right, so we can come back to the timeline, and you'll see that. All right, so they've done this, and the next recon here is they use it during recon using directory service queries. So they're going off to Active Directory and doing group queries. They're looking to see looking at enterprise admins to see all the members, right? So if I take a look, I can actually click on enterprise admins here. And it'll tell me that security and scope and the different activities, directory data. If I go into directory data, I can actually see the direct members. So in this particular case, enterprise admins only has one member, admin user. Let's see, I believe if we go back to, domain admins, we can look at domain admins, and you'll notice here that because they did a query, they've already exposed the NUC Chorus account, and now that they've done this directory query, they know that NUC Chorus is a domain admin. Right, so now that we know, and it's marked as a sensitive account, so we understand that they've now compromised a domain admin account. So then, as you go up, now you actually start seeing we're going from reconnaissance to trying to log in, right? So we get a honey token activity. In this particular case, our honey token account, we're trying to log in, which was designated as Lydia Alexander, and we're showing that it's a failure, but it was just an attempt to log on. But because it is designated as the honey token account, it's going to be flagged immediately, right? So after that goes through, you start looking at suspicious authentication failures, which are indicating like brute force attacks, unusual protocol implementation. This is where you're starting to look at, trying to do malicious tools such as Mimikatz. If we look at victim PC here, we can see well, actually, what I would tell you is, in my particular demo environment, I don't have Windows Defender ATP. If I had Windows Defender ATP attached, we could actually click on this, and you could go to the Windows Defender ATP console here, and you could see that I don't have any machines in my tenant yet, but if you would be able to look at the machine and see that machine had Mimikatz installed, right? So the integration there is pretty cool. All right, so that can indicate that, and so then what happens is, let's see, where were we? Oh, wait, there we go. So unusual protocol implementation, and now they've moved up to they've totally owned NUC Chorus's Kerberos ticket and started using a pass the ticket attack from the admin PC to the victim PC. And you can take a look at that, and it'll show that from admin PC to victim PC, they're using these Kerberos tickets to access the domain. And then ultimately, we're looking at remote execution attempted. So now we're looking at they're using the NUC Chorus account to actually take control of the Contoso DC and install malware on the DC here, right? So it shows you this, unknown WMI method, unknown task, and you can see that it's psexec. So it shows you the actual command line here, psexec, admin user password abc123 abc, command exe. So you can see that they're executing command and putting information on that domain controller. And then once they've done that, it's they replicate out the directory services and then start doing this abnormal modification of sensitive groups. So Nocturus added Monty Rush to the administrators group, right? And it says Nocturus added Monty Rush to administrators, although Nocturus wasn't observed modifying groups during the 11 weeks before this modification. So we look at sensitive groups, but we understand that changes do get made to those groups, but we look at the previous behavior. So we're not going to alert every time somebody gets or one of these groups gets added, because that's a normal part of doing business. But we do take into account overall user behavior so that we can understand that this happened, and it doesn't usually happen from this user, right? And then if there's a role change in your organization, you can come in here and take this alert and say, no, this is normal. We would expect to see this. It was a change, all right? But once you do that, now you've got once you've got their domain admin now, they've got their own account in there. They can actually take this Kerberos golden ticket. And we see that essentially the Kerberos ticket was used over the period of 11 hours, which is your normal timeout for a Kerberos ticket. So now they've got a golden ticket, and even if you delete and get rid of their account, they can still do things in your network just because they've got this golden ticket. They can issue their own new Kerberos tickets, etc. And then it's very difficult to get that out. You have to go do a certificate reset like twice to get everything reset. It's not just a one time. You have to do everything to every machine like 2 times. So that's pretty much the interface here. You've got timeline. We also have some reporting available. So even though that on the timeline, I mentioned the abnormal modification of sensitive groups. We're only going to alert on if we think it's suspicious or abnormal, right? So if it's done by an account that's not usually doing this type of action. But we do keep track of every time a sensitive group is modified, even though we don't necessarily alert on it. You can actually go in here to the reporting and say like lateral movement paths to sensitive accounts, or pull in the summary of all, or modification to sensitive groups. Mine's grayed out because no groups, no modifications were observed. But if this happens, you can download it. Passwords exposed in clear text. So if there's any LDAP authentications that were done in clear text across the wire that we see, you can download all the activity there in the report. Health issues. I have no open health issues here, so you don't really get to see much there. But and normally I'll show you a couple of extra pages here in a moment, or I showed you those already on the other slides. In my particular tenant, I don't have access to some of the other settings there, but for establishing your exclusions and honey token, etc., they can be accessed through the gear icon. All right, so now I'm going to take you back over to the slide deck and show you a few more pieces of information here. So this should switch over here momentarily. Okay, so that should be working. So we'll move on to the next one here, maybe. Oh, there we go. It's suddenly caught up.
And I'll jump in right quick, Travis. We haven't had any questions come in just yet, but if anybody does have questions, don't forget you're able to ask those in the message window.
Yeah. So the next slide here that you should be seeing should say WATP on it. I just wanted to kind of show you that this is, if I had my WATP or WDATP integrated at the moment, you would be able to click on victim PC and see the current status of that machine. And as you'll notice down here, hack tool mimikatz detected. So things like that you'll be able to directly go into and then go right back into Azure ATP. So I thought that was just wanted to show that. I thought that was pretty cool. So some of the attacks that we detect are not limited to just the ones that I showed in the demo site there. For recon, abnormal resource access, account enumeration. DNS enumeration, we showed, SAM account enumeration, in the for compromised credentials, we actually look and see when users typically work, and keep a note of that. So if we see people, suddenly working, abnormal working hours, we'll pull that up, right? Because, people typically work 9 to 5, or 8 to 6 or whatever, and you suddenly see, particular users logging in and doing various activities at odd hours. It's like 2, 3 o'clock in the morning. That's not a typical behavior, so we're going to be able to we're going to alert on that. Brute force using NTLM, sensitive accounts. If a sensitive account gets their passwords or credentials exposed in plain text, service accounts, honey token, protocol. One of the cool things here is abnormal VPN. This feature's not in there quite yet. It should be in the next few weeks here. If you're feeding VPN info into Azure ATP, you'll be able to see that. That'll be pretty cool. That you'll be able to pick up on if somebody in your environment has a VPN client installed on their machine and are going out and attack, going out and trying to access outside your network, etc. Lateral movement, we detect we detect a lot of that. One new thing that we just added was that malicious service creation. I spoke to that briefly. If we see an account going out and trying to install a new service on a domain controller, those are that's one of the methods that attackers use to try to keep access. So that if you go and disable their accounts or delete or close holes, these services will go and re-enable their access. We'll detect a couple different privilege escalations, force pack and silver pack, domain dominance, skeleton key, malware, golden ticket, all that remote execution, and abnormal modification of those sensitive groups. So talk about licensing here just real quick. So Azure ATP is part of EMS E5, whereas EMS E3 is Advanced Threat Analytics. Right, so you do have to have either EMS E5 or standalone license for Azure Advanced Threat Protection, and it is per user. It's so if you have if you want Azure ATP, then you're going to need an Azure EMS E5 license or standalone license, for each user in the directory that it's monitoring. Right. So a little bit here about the differences between ATA and Azure ATP. So environment, they're monitoring today. They're monitoring pretty much the same thing. Or the environment for Azure ATP, it's on premise, right? But you're looking on premise sensors, cloud-based processing, and we're also that cloud data sources. We're integrating one cloud data source today, which is Windows Defender ATP. And right now, Microsoft ATA is all on-premise only. And like I just said, Windows Defender ATP integration is only for Azure ATP, not for ATA. Data storage. If you've looked at some of the data storage requirements for Microsoft ATA on larger environments, it can be in the terabyte ranges, and it requires a SQL license, whereas Defender ATP doesn't have those issues. Deployment. Deployment there. It's just the new Azure Cloud Sensor. For ATA is that ATA Center Gateway, and I'll notice that this is domain controller agent. The Azure ATP sensor can run up to 100,000 packets per second, whereas the ATA Lightweight Gateway will only run up to about 10,000 packets per second. And these are both agents that you install on the domain controllers. But the ATP sensor has been reworked, so it's essentially an order of magnitude more efficient and faster than the ATA Lightweight Gateway. Updates. This has been an interesting point. Azure ATP, because it's a cloud service, we can iterate this very quickly. Right, so everything that as you've seen with Azure for years now, we make these changes as quickly as we can, sending updates. Whereas ATA, it's a manual process via the ATA Center. You have to update the ATA Center. You have to update all the lightweight gateways and the physical gateways with all the updates yourself. Licensing, again, it's a EMS or M365. It's an E5 license or standalone, and ATA comes with EMS E3. And then kind of along the releases, we're going to be regularly releasing updates to Azure ATP. ATA, the current version is 1.9, and it RTM'd just last month. And, oops. There we go. All right. So just one last word here on why you would want to use Azure Advanced Threat Protection. It's very it's very fast. Using that behavioral analytics, we're looking at what users are doing and when they're doing it, and changes in behavior. And we're trying to focus on what's really important, right? Using that simple attack timeline on what we've seen over and over again. We've worked very hard to reduce the fatigue of false positives, where while we're looking at every action, we're trying to use some intelligence and some machine learning there to decide which events are false positives, and reduce that, and only alert on the actual attack events. And then obviously, because this is a cloud, you're able to protect at scale, right? And today Azure ATP is looking at your on-prem Active Directory authentications and behaviors. Soon enough it'll have Azure Active Directory integration as well. And this is best in class security. And this is Microsoft Intelligent Security Graph. I've heard from different customers and partners that there's a little bit of confusion on what the Intelligent Security Graph is. It's not a SIEM. It's not a Splunk competitor. It's not a product per se that you can go buy or license. Just the security graph. The security graph is the culmination of all of the telemetry data that Microsoft receives from all of its products, right? So all the telemetry from Windows Defender ATP, from Windows 10, just as an OS, all that telemetry data that gets sent back, all of the information that comes through Office 365, various attacks. I mentioned the safe links earlier from Office ATP, where we're actually doing a detonation of those URLs kind of in a safe space in the cloud before we're passing the real URL onto the client to verify that at runtime that it's a safe link. all of that threat intelligence, all of that telemetry is being fed back into what we call the intelligence security graph. The security graph then is utilized by the entire ecosystem to provide protection. So once we identify a threat, in a single email, in a single tenant, regardless of where it is, we can then take that threat intelligence and apply that same protection across every tenant, every mailbox, every endpoint, right? Immediately, right? So it's not like it's not like the downloading signatures, every other day, as in past, right? It's not so much as viruses anymore. It's the threats are a lot different. So being able to keep that information up to date and agile and respond quicker than than most of our competitors, or maybe even all of our competitors, it's very important to keep your endpoint safe and to be trusted. So I'll open up the floor to some questions and answers.
All right. Thanks, Travis. I appreciate that. Always appreciate when demos are brought into the presentation as well. Right now, we don't have any questions, but for those attending, we will stick around for a little while if questions do pop up. I do want to make you aware of the upcoming Modern Workplace call schedule. On May 1st, we will have our Windows and Devices call on Windows Analytics. 5/11 or May 11th will be our productivity call. 5/15 will be our May security call, where we'll discuss security is not a product. And then May 22nd will be our next Windows and Devices call, where Windows IoT will be the topic. All right. I don't see any questions coming in, Travis, so just one last thank you for everyone that joined today. The presentation I will post on the Yammer community shortly after the call, and then the call recording will be available via our YouTube channel here in a day or two, and I provided the links to those in the message window. And also, thanks again to you, Travis, for the presentation today.
No, my pleasure. Thank you all for coming.
All right. I appreciate it. Thanks, everyone. Have a great day.